Welcome to Ray Engineering Mechanics. This is a question on 2D motion. We are still on 2D. The question says the hydraulic cylinder BD, this BD, exerts on a member ABC a force P directed along line BD, this is our B to D, knowing that P must have a 750 Newton component perpendicular to member ABC. Don't forget that if there is a particular force P that is acting along this line BD, the force will go in this particular direction. It will go in this direction, as you can see, along this BD. Don't forget this particular force we have, since it is acting downward like this, it will have both the vertical and the horizontal components. Are you guys with me? It will have both the vertical and the horizontal components. So in that downward direction, so the question now says determine the magnitude of force P. We are determining the magnitude of force P. So now let's analyze this particular hydraulic cylinder first. So as you can see, from this point to this particular point here, where this particular angle is making 60 degrees to the vertical, let's draw a straight line in this. It must touch those. Okay, this is the straight line, this is the vertical component. So let's draw our horizontal component in this direction. So as you can see, if this is 60 to the vertical, the angle here, the angle in this particular one, the small one here, will be what? 30 degree. Are you with me? So let me use a writing material stuff. The small one there will be 30 degree. So it will be 30 degree. So as you can see, so that means in this case we are having 30 degree in this. So like I've said, from this point to this point is 30 degree, where I put the dots, the red dots. Abi, is it red? Yeah. So then as you can see, this particular one here where the blue dot is perpendicular. As you can see, that's 90 degree. So that means from here to here will be what? 120 degree. 120 degree. So that's from here to here. So if from here to here is 120 degree, don't forget this particular, from here, since this particular stuff is perpendicular, so and if from here to here is 50, so that means from here to here is also what? 40 degree. So if from here to here is 40 degree, from here to here is what? 20 degree also. So if from here to here is 20 degree, so that's where we are coming. Since we've actually know that from this particular spot is 20 degree, so we can create another parallel line that will be parallel to this line A, B, and C. So let's create a parallel line, that is parallel to A, B, and C. So since this particular line is parallel to A, B, and C, let's extend this particular one outside. So since it is parallel to this A, B, and C, this particular line BD looks more like the transversal line that cuts this particular two parallel line. And from our knowledge, we know this particular angle here will be alternate to the angle here. So if this particular angle here is alternate to the angle here, so that means in this case we will be having our force. I will be having our force in this direction. We'll be having our force in this direction. So that means this will be our P. This will be our PY. This particular spot will be our PY, and also this particular spot will be our what? PX. And this particular one will be the magnitude. Don't forget the red line is our PY, which is the vertical component. The green dot is our PX, which is the horizontal component, and the orange dot is our P magnitude. Don't forget from here to here, from this particular angle here is what? 20 degree. 20 degree. The yellow dot is 20 degree. Since we already know the yellow dot is 20 degree, resolving this particular stuff, resolving this particular stuff, so we already know resolving it in x component, sorry, in y component, we know our sine, let's call it theta, sine theta to be equals to p of y over your p, which is the magnitude of that particular p. So that means your p will now be p of y over sine theta. And we already know our, so I have to change my pen, and we already know this is py sine theta over sine theta. So then our p will be equals to the p along the y-axis, which is 750 Newton, all over your sine of 20 degree. So that's what 750 divided by sine, divided by sine of 20 degree, which is 2192.85 Newton. That's your p magnitude. Now, since we already know our p magnitude, which is the orange dot according to this diagram, so we can actually get this green dot, which is our px. So question B now. B says its components parallel to ABC. This is the okay, as you can see, this is our parallel component, the green line. As you can see, this is our parallel component, because since we've created another line which is parallel to this ABC, so this will be our parallel px, which is the parallel component to ABC. So that means we already know our parallel component will be from, by resolving it, we have our cos theta, because this is adjacent to this particular 20 degree, and this is opposite to this particular 20 degree. Since we are looking for the adjacent one, we use cos theta. So that means our cos theta is equals to the px, which is or p parallel all over your magnitude of p. So that means your px will be equals to cos theta dot p. So that means your px will be equals to cos of 20 degree dot 2192.85. So that means your px is equals to 2192.85 times cos of 20 degree. So you have your px to be 2060.6 Newton. So that way, here comes to the end of the question. So as you can see, we've already dismantled this particular question. These are our p magnitude and these are px. Here comes to the end of this. Thank you very much. Please subscribe to my YouTube channel and always turn on the notification button.